Today, by the efforts of IESL University of Peradeniya Chapter and Electrical and Electronic Engineering Society of University of Peradeniya, the fourth episode of Innovations, a talk on image-based insulator condition monitoring system for modern power systems is presented to you. I am Gavishta Liyanage and I welcome you all for the today's session. Let's have a little peek of a few previous episodes of Innovations.
Ladies and gentlemen, hope you are all staying safe and well in these troubled times. I am Janaka Narayana and I'll be your host this evening. I welcome you all to the second episode of Inven organized by the Electrical Engineering Society of University of Moratuwa in collaboration with the Undergraduate Inventor of the Year Committee of the Institute of Engineers, Sri Lanka.
Good evening, everyone. On behalf of the Electrical Engineering Department and Electrical Engineering Society of University of Moratuwa, first and foremost, I would like to warmly welcome our today's session guest speaker, Engineer Dasun Arandarage, Engineer Nawudina Kankanamge, Dr. Rasara Samarasinghe, and Dr. Tushara Damayanti. Next up, I want to welcome everyone from the IESL and Electrical Engineering Department who participated with us today to make this event a huge success.
So these are the activities that is being done by the bid preparation teams in the with the contractors. So these are the most important set of skills for a bid preparation team. Leadership skills with PR, communication skills, attention to detail, negotiation skills, and time management. Negotiation skills is really important to make your bid to get your price to the winning price.
To shift from conventional power to renewable power, reactive power, short circuit current, and frequency stability are all reduced when large conventional rotary generators are removed from the grid. So how do we manage this issue?
So here successfully concludes the second episode of the Innovations webinar series, giving us a vast knowledge on engineering projects, designing, planning, executing, and commissioning.
With the hope of meeting you all again with a third session, I'm signing off. I'm Janaka Narayana. Stay safe and good night.
As Stephen Johnson, a science author, once said, if you look at history, innovation doesn't come just from giving people incentives. It comes from creating environments where their ideas can connect. Exposing the next generation of engineers' minds to great innovations is a form of creating the environment for us youngsters to think out of the box. To get this exposure, the webinar series Innovations was collaboratively initiated by the IESL Undergraduate Invent of the Year Committee and other IESL Student Chapters in Sri Lanka. Here, insights on fundamental and state-of-the-art areas of engineering industry and its relation with innovations are discussed with engineers from different disciplines of engineering. To welcome you all for today's session, I cordially invite Committee Member of IESL Student Chapter of University of Peradeniya, IESL Junior Invent of the Year Committee Member, Chairman of IESL Undergraduate Invent of the Year Subcommittee, and my fellow colleague, Mr. Akila Vijayasinghe.
Good evening, all. It's my pleasure to welcome such an energetic and committed crowd who joined this webinar today to gain maximum knowledge in real-world applications and industry from a talented engineer. I take this opportunity to warmly welcome today's guest speaker, Engineer Bhagya Wickramasinghe, Chairman of IESL UIY Committee, Engineer Nawudina Kankanamge, Liaison Officer of IESL Student Chapter in University of Peradeniya, Engineer Mahanama Disanayaka, and all other participants who have joined this webinar. In brief, this is the 4th episode of the Innovations program. This episode is a collaboration output by the IESL UIY committee, IESL Student Chapter of the University of Peradeniya, and EES of the University of Peradeniya. We all understand the importance of science, technology, and innovation in the industry and the ways in which they are transforming the world. I'm pretty sure that this webinar series will be a great platform that ensures the engineering undergraduates think out of the box, seek knowledge, and motivate them to do something different and valuable as young engineering undergraduates and then after graduating as engineers. I believe that by participating in this webinar, we are in the right place and at the right time. So I kindly request you to get the maximum out of this informative webinar by actively participating. Without taking much time, I will conclude the welcome speech and wish you all a very successful webinar. Thank you. Over to you, Gausta.
Thank you, Akila. Okay, so to give a thorough understanding on innovations and undergraduate invent of the year, I now like to invite Engineer Navodana Kankanamge, Chartered Electrical Engineer, Chief Engineer of Ceylon Electricity Board, Council Member of Invent of the Year and Undergraduate Invent of the Year Executive Committee.
Thank you very much, MD. Actually, inventions, many of the things surrounding are invented by man. Junior and undergraduate inventor that IESL is conducting to promote inventions and innovation. Parallel, in OVATIONS, this is the program, a series of sessions discussing new things, new innovative matters, and the out-of-box thinking pattern while promote industrial inventions and innovation. Here,
there seems to be a connection issue with Engineer Kankanamge.
is there. So, I hope we get this innovation series to encourage school students and to become more innovative and thinkers. And some say there's a gap between industry and undergraduate. So this would be a good opportunity.
There seems to be a connection issue with Engineer Kankanamge. To carry on with the session, I will speak a few words about our speaker today. He received his Bachelor in Electrical and Industrial Engineering with honors from the University of Ruhun in 2013 and completed the Master's degree of Electrical and Electronic Engineering at University of Peradeniya. He now he has used his knowledge as an electrical engineer at Sierra Construction till 2015 and at CD thereafter, and is now currently serving in the Transmission, Operation and Maintenance Central Unit of CEB. His work is not limited to the industry. Modern power system, porcelain insulators are vastly used, and the constant monitoring, carrying out tests, and maintenance of these insulators is troublesome. For this issue, he developed a solution where simply taking a photo of the insulator will diagnose the insulator's condition. For that innovative idea, he was among the best 2 innovators at CEB Innovations 2020. So without further ado, I invite our guest speaker for the day, Engineer Bhagya Wickramasinghe, to continue the session. Over to you, sir.
Good evening, everyone. I hope that all of you can hear me properly.
Yes.
Yeah, okay. And right. Hope that you can see my presentation slide. Gavista?
Yeah.
Yeah, okay.
You can see how, I think it's Google Chrome that's been open.
Is it okay, or do you do you want me to remove the video? Better, nah?
No, that's fine. There doesn't seem to be any bandwidth issues.
Yeah, okay. So again, good evening, everyone. And I am Bhagya Wickramasinghe, and I am about to deliver the guest speech of Inven Ovations, episode 4. And as Gavster told about me, I was graduated from University of Peradeniya in 2013. Then after graduation, I worked at a private construction company from 2013 to 2015. Then I joined with CB in 2015. First appointment was as a protection and centralized service engineer. Then from 2016 September onwards, I'm currently working at Transmission Operation and Maintenance Branch Central Unit. And okay, I had completed my MSc Engineering, Electrical and Electronic at University of Peradeniya. Also, I am a chartered engineer. Regarding my duties of the job scope, I am responsible of operation and maintenance of 132, 33 kV and 220 to 132 switching grid substations in transmission network. Also, I am involved with maintenance of 220 and 132 kV transmission lines of the transmission network. Also, routine maintenance of primary equipments, also replacing the faulty equipments. Yeah, sure.
Your presentation is not visible. It's a different screen that you have opened. You have shared with us.
Now?
Yeah, now it's visible.
Sorry. And analyzing fault occurs in the transmission network and finding ways to rectify them. Condition monitoring of power transformers and other primary equipments, also commissioning witnessing of newly built GSS. Those are my job scope. I just gave a brief introduction. What am I doing in CEB and what are the connections with the thing I have been innovated? So these are the things which I'm currently doing in my job scope. And I was chosen to deliver the guest speech here today because of this. At the Innovation Awards 2020, my innovation, the image-based insulator condition monitoring system, it was selected as one of the 2 best innovations in that night. And and it was a proud moment too, yeah. And today, I'm mainly focusing on my presentation regarding this rewarded innovation. What did I do with the innovation? What was the content, and what is this innovation about? And my main task, the innovation is mainly about finding a correlation of an image of the insulator surface with its aging. As we know, the insulators with the aging, the surface change. And that surface change, if we can identify that surface change with an image, that will be a huge advantage in order to condition monitoring of that insulators. So that was my main task, find a correlation of an image of the insulator surface with its aging. And as we know, the world trend is now onto the online condition monitoring tools, inventing online condition monitoring tools, because of the heavy loadings of the transmission lines and the number of insulators of a transmission lines are very high. Because of that, offline condition monitoring of insulators is not feasible. Actually, we cannot take transmission line outages for months. Therefore, online condition monitoring coming into the picture. So I thought of putting a simple way of condition monitoring of insulators if I can find a correlation of that image with the surface and its age. So my main objective of this innovation was finding that correlation and also develop an Android application to use as an online condition monitoring tool. And I hope that I was able to develop it, and I'm so much grateful because CEP has appointed a committee to develop further this tool and get it work done in CEP as well. So it's a great honor. Yeah. So I'll go with the my presentation without wasting much time. This was done in my MSc. My main supervisor was Dr. Sarat Kumara. Now he is currently in Sweden. And my co-supervisors were Professor Manjula Fernando and Dr. Kapila Bandara. The Dr. Kapila Bandara was actually involved in this project, not as a supervisor, but as a guider. He was the one who guided throughout the project as well as throughout this innovation competition as well. And this is the latest incident which we faced in our transmission line network. This happened in April 29th. The Mondragal GS was dead due to the tripping of Ampara Mondragal transmission line at 9:25 a.m. And then we had to find what was the cause. After finding the cause, it was in this tower number 3, insulator flashing over. We found the place, then we have replaced the insulators, then we were able to re-energize the Mondragal grid on following next day at 2:83.56 p.m. So as you can see, it's almost 2 days. Mondragal GS was dead. Replacing this insulator set is not much of thing to do. It's very cheap. But because of the flash-in over, line outage, power interruptions, and power failures are the things we have to consider. Of course, it's money and it's time, both. So as that point of view, condition monitoring of those insulators are very much essential. But because of the price is very much low, we are not giving our best on condition monitoring of the insulators. But it plays a vital role in this transmission line as well. It serves 2 important functions. The main first thing is to isolate the conductor. As we know, the conductor carries 132 kV or 220 kV, and the tower is grounded. So it gives the voltage bridge across the conductor to the tower, and also it serves as a mechanical support for the conductor as well. We spent just 5% of the direct capital which we spend for a transmission line, just 5%. of a total cost of a transmission line towards the insulators. But 70% of line outages happen due to the failures of insulators, 70%. And also we spend 50% of maintenance costs in order to maintain the insulators, replacing or whatever. So as you can see, if even though the first number is 5%, the last two numbers are very much higher. So in the transmission line point of view, aging happens, this expansion of cement, mechanical and electrical stressors, hardware corrosion. Aging is not that it's about after 5 years or after 10 years or after 15 years. Aging is something different. The same insulators which we connected with our transmission line, if it is in a heavy lightning area, or if it is in a coastal area, or if it is in a heavy loaded transmission line, the aging can be very faster compared to another normal transmission line. Yeah. For an example, insulators at Olpitia Colonnava line can be aging faster than Ukwelapalle line. So we cannot exactly say this is the period of an insulator. This is the age of an insulator. Aging depends on some variables like lightning, loading, coastal area, environment, atmospheric conditions, etc. And these are the two techniques which currently used in power system industry to online condition monitoring of the insulators, the hypo test and electrical field mapping. As you can see, the person has to climb up that tower and get close this box in order to measure the leakage current. In order to measure the leakage current, so it is somewhat a time-taking activity because this person has to climb every tower and get this box closer to the every insulator, and the person point of view, it's very dangerous, and the time point of view, it's very time-consuming activity. So basically, those are the two tests which we are currently practicing as online condition monitoring tool, but due to the difficulties of that, it is rarely used. So what I did was, I have selected my sample of porcelain insulators, 10 brand new insulators, and another 10 used insulators which were dismantled of Badulla Mondraga transmission line, and also another 10 porcelain insulators which were about to dispose at the transmission line maintenance unit. And also the glass insulators, same like that. This is my sample, porcelain and glass insulators. Then I have taken them to the Peradeniya HV laboratory in order to measure the flashover voltage and the leakage current. First, now, one insulator rated voltage, one insulator disc. This is a disc. The rated voltage is 11 kV. 11 kV is RMS value, 3-phase. So in order to find the optimum value, we have to take the peak value. So we have to multiply it by √2, and also we have to find the single phase value. So we have to divide it by √3. So approximate value is 10 kV, the rated single phase insulator peak value. 4 steps, 100% means 10 kV, 50% of that 5 kV. Likewise, in these 4 steps, I have applied these 4 steps of voltages up to here. Then I have connected a 1 kilo ohm resistance, and by using these 2 probes, it was connected with the oscilloscope. And then I got the voltage graph here. By using this voltage graph, V equals IR, I was able to calculate the leakage current. So from that, I calculate all the leakage currents in these 4 steps. Then I measured the flashover voltage at dry condition. That was flashing over of an insulator. Hope that you were able to see that video. Akila, did you able to see that video?
It's not playing, sir. It's not playing.
I have already played it, the last one.
We can't see, sir.
Okay.
Now we can see, sir.
Okay.
But sound is not available.
Okay. Now do tell me, how can I get with that sound?
Did you tick those 2 options when you are sharing the slide?
Okay. Now?
Yes, sir. Now we can hear.
Okay, thank you. That was a flashing over of an insulator. And then I have calculated the leakage current at the wet condition also, similar as before, and the flashover voltage at the wet condition also. Now I do have the my laboratory results. I have tabulated them. Based on my laboratory results, this is the oscilloscope voltage graph kV value. And from V equals IR, I was able to calculate the leakage current. It's in the microampere range. And the flashover voltage, I have tested flashover 3 times and got the average value here. This is the dry condition and this is the wet condition. So according to the IEC standard, leakage current at 200%, it should be higher than, it should be less than 300 microampere. So, and I get the moderate group 300 and 350. And if it is higher than 350, the insulator is bad. The flashover voltage, if it is higher than 70 kV, it is good. If it is 55 to 70, it is moderate. If it is less than 50, it is bad. So according to my laboratory results, I have divided my insulator sample into good, moderate, and bad, as well as the glass insulators. Okay. Now I have my sample. I have got good insulators, I have got moderate insulators, and I have got bad insulators as well. Now all I got to do is find a relationship with that surfaces in the good compared to the bad or moderate. So that was my next task, find a relationship with that surface changes according to the good and bad. So first of all, I tried this hyperspectral images thing, and it was too much complicated and complex as well. And my main task was to do finding an online condition monitoring tool. So in that point of view, this hyperspectral images thing, yeah, I had to skip that. Then the hydrophobicity classification. It is a known, it is well proven a thing for the polymer insulators, but not for the porcelain insulators or not for the glass insulators. I tried to find a correlation, but I was unable to find any. Then I had to go with the thermal images and the amount of reflection light. Regarding the thermal images also, as you can see, the heat is not dissipated, it's not distributed homogeneously of an insulator. So I was unable to find any correlation of this heat distribution and the surface changes, that means the aging. So then first, I used this MATLAB average RGB value MATLAB average RGB value calculating code from the MATLAB. By uploading some photos to it, I was able to find a hint of a relationship with that average RGB value and the aging of the insulator. That means good insulators has a different good reflection coefficient. The bad ones has a less value than the good one. So that was a huge relief to me as well. From that point of view, I have taken my next step to developing an application, because we cannot take an insulator photo and get it down and uploading it to a MATLAB codings and find the reflection coefficient. So it will be just like a hypo test or a electrical field mapping. So I had to go with an developing an application in order to use this as an online condition monitoring tool. So for that, I have selected Android application, implementing an Android application. The main three reasons for choosing that: the Android phones are commonly used in nowadays, and also then I can use a drone clearly to use to take photos, and simultaneously we can diagnose the condition of the insulator with my application. And also developing an Android application is very much user-friendly. That Android Studio software is very much user-friendly software. By using these file libraries, I was able to get the code, and then I was able to calculate the average RGB value of the insulator photos as well. Then these are the average RGB values of my insulator samples, and I forgot to tell you that the reflection coefficient was not working very accurately for glass insulators, because at glass insulators, other than the reflection, there was some transmission through the glass. So the glass insulators, I had to skip glass insulators, adding with this reflection coefficient phenomena. And this is the flow chart of my application. I'm uploading the insulator photo. Then by using that photo, I have to crop a surface area. Then that surface area will be transferred into a black and white image. As you know that the images are created with created by megapixels. At a pixel, there are three components: R, G, and B.
Excuse me, sir.
Yeah, sure.
If you're sharing a video, we cannot see it.
No, I'm sharing a PDF actually. Okay.
It's not visible.
Now?
Yes.
Okay. I'm uploading the insulator photo. At that insulator photo, I have to crop a surface. Then that cropped surface is transformed into the black and white image. As we know that images are created with pixels. At a pixel, there are three components, R, G, and B. Every image is created with this RGB components. So in that cropped area, I'm calculating if there are n number of whiskers, there are n number of R components. So I'm calculating that from R1 to Rn, and G components as well, G1 to Gn, and B components as well, B1 to Bn, and I'm dividing it by 3 into n. So this is how I got the average RGB value. And if it is higher than 127, the insulator condition is bad. If it is less than 127, the insulator condition is good. Then I'm generating a report as well. This 127, I have taken it as the least value of the bad insulator. Okay, hope you can see the presentation.
Yes, sir.
Then these are the case studies which I have done. I'm not supposed to show every case study because there are 6 videos and it will take some time. I'll only show you how the this application works. This is the application icon. Here you can see that this is the InsuTest icon of that my application. When you click it, it goes to the front interface like this. Then when we slide it, it goes to the second page, and I have kept provisions to the glass insulators as well. And if we try to proceed without selecting any of these insulator type, there will be an error message coming. Please select insulator type. Then after selecting porcelain insulator, we can click browse. After clicking that browse, it will go directly to the select source option. From that, now here I'm gonna show you a sample case. So I'll go to the my photo library, and then I'm gonna select the insulator, this one. In that insulator, like this, I have to select an area like that. After selecting the area, then I can crop it, then simply generate report. When I click this generate report, the condition will be appear like this. Then I can get into the report as well. In that report, the summation of RGB values and what was the mean value, all are indicated there. Then I'm gonna show you the same insulator. I'm gonna crop the surface in a different angle. Same insulator. Now I'm gonna crop it like this. So if I generate report, the condition is coming still as good, and also the values. Then I'm gonna show you a flashover insulator. I'm going to upload a flashover insulator to my application. This one. Okay. So this has been already flashed over. As you can see, a chip has been removed. Now it is proven that the growth of the leakage current as well as the flashover voltage is homogeneous. That means the leakage current flow through the surface homogeneously. And maybe because of the material strength, this part has been removed just because of the material strength. Other than that, the leakage current and the flashover voltages are same in any part of the insulator. So I'm gonna crop a part other than that flash over chip removed path. And then generate report. As you can see, the condition is coming as bad. I'll show you again. A different part of the insulator. I'm gonna take it this part, and it also coming as bad. So as you can see, as I'm cropping an area, the angle of the photo taker is independent. So we can take from any angle. We can fly the drone over the transmission line and get a photo of any angle, because we are taking a cropped area of that insulator. Also, I have proven that the effect of image size, that means whether it is a kilobyte image or whether it is a megabyte image, whatever, as we are taking the average value, the effect of image size is independent. Also, the effect of light. Now, we are calculating the reflection coefficient. That means it is proportional to the amount of light which coming onto the insulator. So, kind of a thing. That means in dark condition, the reflection coefficient will be low, because the amount of light putting onto the insulator is low. Because of that, the effect of light level also independent. Likewise, the effect of surface condition, effect of biological growth, I have proven that by these case studies that my application is working 100%. Then, in order to prove the field validation, I have chosen 9 insulators from the field. I have calculated the RGB value from my application, and then I have taken them to the HU laboratory, and I measured the leakage current at the wet condition. Then from those laboratory results to my application results, they were synchronized 100%. So ultimate task is to do something like this. Ultimate task is to do something like this: fly a drone over a transmission line, take a snap of the insulator set, simultaneously run the application and upload the photo. Like that, cropped it, generate report, can get the condition of that particular insulator disk. And at this point of view, we have to upload the insulator set one by one, the disk. In our future modifications, we are about to create an array which we can upload the insulator set one time and get 12 reports for the whole insulator disk. At this point of view, we have to upload one by one and take the conditions of the insulators. and future improvements which we are about to done. Future improvements which we are about to done, and we have kept a provision to the glass insulators as well. So Dr. Kapila Bandari is very much keen on improving this application. So we are thought of getting that corona sound and take a correlation. If we can find a correlation for the glass insulators, we can proceed it as well. Then finding another category. Now here it is, we are giving only good and bad. To find a new category called moderate, and also to develop an array to run the whole insulator set from a single photo. Now, at this point of view, we have to upload the same photo 12 times in order to get 12 reports of the 12 disks in the same array. So if we can get the 12 reports at a single photo uploading, it will be a time-saving thing. So that is my presentation regarding my innovation thing. So if anyone have a question, please do ask now.
Thank you, sir, for the wonderful presentation. And as I said, if anyone have any questions, please unmute yourself and ask, or you can drop it on the chat box.
Sir, I think you can hear me. Can you tell us about how you manage your work at CEB with doing research work? I have heard that doing research while working is pretty difficult. And can you give some
advice? Okay, that's a good question actually. And the secret behind that kind of a thing is finding a mentor like Dr. Kapila Bandara. The full credit should go to him, and he's the one who's carrying a PhD and having that UNA, research UNA. Research UNA තියෙන කෙනෙක් එක්ක set වුණොත්, even though you got so much work at CEB, I know that there are so much work to be done, but if you collaborate with a person like that, there are so much of persons like that in CEB, and we have to identify them, and then only we can work like that. And also at the power industry, the CEB is giving a huge opportunity, because now testing those insulators, I cannot do it if I'm working at a private sector. I won't be able to get those insulators to be tested. So at CEB, there are those resources. We can all we got to do is we got to manage them, and we got to get work from them. Now, my experience is only about 8 years in this industry and 6 years in the CEB. But my only advice to undergraduates like you is create your own passion of working. There are people who like to follow others. From their point of view, it's safe. Actually, it's safe if we are doing a thing which one has already done, so we are safe, because but if you can challenge, and if you can get that fever, you can create an icon of you. Wherever in CB or wherever the industry you are working, you can create an icon of you. So we are paid to think as engineers, so we have to work as engineers. That's all.
Thank you, sir.
Any other questions? Sorry. Any other question?
Do we have any more questions? So we'll wait for like 2-3 minutes.
Yeah, it's okay. I can wait. And it's glad to hear that nobody got questions. So that means either the presentation is fully clear or either nothing has been cleared to you. I don't know whether it has been fully cleared or there's so much complicated in my presentation.
Excuse me, sir.
Yeah, sure.
Sir, how did you cancel the angle of the photo taken when doing your classification?
I didn't get you, please.
You had to take the photo of the insulator and you can crop.
Yeah, I can crop the insulator surface with any
then
angle.
The angle of the photo will does not make any difference in your classification.
Yeah, it doesn't make any difference because now, even though we take the insulator surface from the outer or inner or wherever, we are just uploading and cropping some part of that insulator. That means either we can take the full image of the insulator, but only RGB value will be calculated at the cropped area. So whatever the angle we take the photo, it doesn't count because we are only calculating the RGB values at the cropped area. So we can select the cropped area wherever section as we please. Hope you got the answer for that question.
Thank you, sir.
Do we have any more questions?
Okay.
So sorry.
Yeah. Okay. So I hope that no more questions from you. And my last advice to undergraduates like you, and first of all, I would like to thank the crew for inviting me to deliver my experience as well as my innovation to you, and mainly that Brother Akila to coordinating me throughout the past week regarding this one. And my final advice to the undergraduates like you is, when you are coming to the industry, keep your all the academic stuff at the faculty and get into the industry for working. While working at the industry, now I am working at CB and I have been innovated a thing which I have been working in my duty responsibility. That means the insulators. Likewise, when you are doing your thing at the industry, you will meet with some difficulties. Find answers for those difficulties, then you will create your own researches, you will create your own innovations, you will create with your own tasks. Other than following the same thing which the past engineers have followed, you can survive. No worries, you can survive. But my advice is, rather than surviving at the industry, create your own icon, create your own passion of working. That will be a huge benefit to you. I'm not telling that you can immerse from the other engineers, but it's somewhat self-satisfaction, and also you will be rewarded like this. So see that I have been able to innovate something like that. Because of that, I got the opportunity to deliver a presentation to you also. Likewise, you will be rewarded, and that thing calls the self-satisfaction. So and now in my past 6 years of experience, the undergraduates are coming to my working place as well. All of those, I'm not telling all, majority of the undergraduates are now so much lazy. I'm not asking you to follow up every and each thing at the your job point of view. I'm just telling you to do whatever you are about to do, and do it with your own passion. That's all. Create your own passion. That's my advice. And Gavishta, I hope that we are about to wind up the session.
Yes, sir.
Okay.
Yes, thank you for your words. And if Engineer Kankanamge is present.
Yes, yeah, very sorry. Previously, because of the instability of internet connection, I could not be able to deliver what I need to know. Actually, Bhagya almost told everything. After graduating, you are coming to the industry and working. I came to the industry in 2009. From there, around 11 years, I am doing and performing as an electrical engineer in the industry. But now, once you are coming and once we are coming, Bhagya is joining with CB, there are so many things. Sometimes we can develop our own system to improve the efficiency or reduce the material or reduce the cost. There are so many innovative things we could be able to do in this industry. Otherwise, you can actually come here and do the same thing while our seniors and the people are doing. You can survive, as Bhagya correctly said, but you can come with your own systems and own innovative ideas, and you can improve also. You know, in CB now we have a very good breakdown app we call CB Care. It is also a very good innovative product of my good friend Jagat. He joined CB with me last with our batch, and those are self-satisfaction projects that Bhagya did. Now, because of this system also Bhagya did, we can identify fault insulator very quickly. Sometimes the cost is not the thing. We can restore the breakdown immediately. Therefore, we can serve our customers very quickly. Those are the things. And if you have any matters, IESL, someone becoming associate member, how you become you can ask those questions. Good open forum, and always do what industry need. Sometimes some students and people are doing very good innovative things, but those things are not essential thing for the industry. There are so many burning issues, but nobody cares. So that is also, you have to take those things, you have to take those concerns of the industry once you are doing projects.
It seems like his connection was lost. Okay, so Thank you, Engineer Bhagya, for your words and enlightening us about your research. And now, before we wind up the session, I invite you all to turn on your cameras to take a snapshot to commemorate this event. Okay, I'll be taking us photo now. So please smile, everybody. Okay, great. Now to deliver the vote of thanks, I'd like to invite the Secretary of Electrical and Electronic Engineering Society and my fellow colleague, Mr. Sanduru Adasuriya.
Good evening. On behalf of all the students who participated today, I would like to thank Engineer Bhagya Wickramasinghe for delivering such a valuable session. I hope all the participants get inspired to do research work even after they enter into the industry. So thank you again, sir. And next, I would like to thank Engineer Navodana Kankanamge for the guidance given to us to succeed this program. And next, I share my gratitude with Engineer Mahana Disanayaka for his support to success this event. Then I would like to thank all the members of IESL Student Chapter and all the committee members of IES. They help a lot to organize this event. And at last but not least, I would like to thank all the participants who joined today. I think you got most out of this session, and I hope you will join in our next sessions as well. Thank you.
Thank you, Sandru. So that marks the end of today's session. So, and I hope you all a pleasant evening. Goodbye.